Hi, I'm in Austin, Texas at the Texas State Capitol. Thought I'd talk for a moment about a technology I've been studying for a number of months now called Spark, Apache Spark. Apache Spark grew out of the MapReduce world, way of processing large amounts of data in a distributed fashion to detect patterns, analyze, to find answers within that data. Quite often it was MapReduce started more on a textual basis out of search engines, but Spark has transformed it a bit in that it has more quantitative aspects to it. There's a specific piece of Spark that is interesting I want to talk about in this episode. It's about the data access method. If we talk about scanning large amounts of data, a metric engine, as I've talked about, requires being able to read a lot of data. The more data you can read, the more data you can analyze, the greater the patterns you can find, the greater the balances and positions you can create. Everything can be created from the transactional data, but we have to have balances to begin our analysis. So Spark gives us the ability to do that in a certain sense, but if we store the data that we're accessing in forms that make it easier for programmers to access, as opposed to faster for machines to access, then we're going backwards against the idea of being able to scan more and more data. For example, if you use a relational database, relational databases are very helpful for storing transactions and for retrieving specific records for reports. But that process of scanning a lot of data to create balances, that's not a process that an indexed access typically is very helpful for. The process and the speed of a relational database often can get in the way of scanning large amounts of data. It takes more CPU time, more compute capacity to take and uncrypt the data from a database, or to scan the data in an index and then go find the actual transaction data which is stored elsewhere. That process speeds up programmers quite often. Quite often SQL as a language gets used because it makes the programmers faster. It's a language that's easy to understand and easy to know and is known ubiquitously. That process, though, of speeding up programmers can be counterintuitive or counterproductive to the process of speeding up computers. If we optimize programmer speed, we end up reducing the amount of data we scan, which reduces the kind of analytics we can get out of our data, reduces the nature of the metric engine to something that looks much more like a pre-calculated catalog of answers, rather than something that creates those answers when we ask for them specifically. So this process of determining what sort of data storage we will use in the database, in the way we create the metric engine, is critical to creating the most flexible and performant metric engine possible.